Hello world, it's Calcutron here with part 2 of our snake game tutorial. In the last episode, we left off with a snake that would move all around the screen in some direction D. Let's take a look at the program that we finished with. So we had the snake with a length of 2, and every time we hit second, it moves to the right, or it changes direction. Now in this episode, we're going to make it so that we can move in any direction, and we're going to allow our snake to grow in length. So let's start by modifying the code that we have to move the snake. So our solution was to do if getKey is equal to 21, then update our direction D. Now we're going to remove this, and instead we're going to want to store our getKey into a more permanent variable. So we're going to do getKey stored into K, and I guess while we're on the subject, let's go ahead and change this while loop so that it's not infinite, so we don't have to press on every time we want to break out of our program. That's not a very user-friendly design. We want to change our infinite while loop that continues running this game and updating our snake. We want to change this to be a repeat loop, and we're going to want to repeat while K, or repeat until K is equal to 45, which is the clear button. And later we're also going to repeat until our snake eats itself, which is when you lose the game. Alright, so now that we have our key press stored into K, we're going to test if K is one of our arrow keys. So if K is equal to 34, that's the down arrow key, or, and this is I guess a little bit tricky, or 1 is greater than or equal to the absolute value of K minus 25. So our left, up, and right movement keys correspond to the key codes of 24, 25, and 26. So the absolute value of K minus 25 is the key's distance from key 25, and if that is less than or equal to 1, then we know it's either 24, 25, or 26, and then we also need to check if it's 34. So this we'll check our code for if any of the movement keys is pressed, and then we're going to do something kind of fancy in order to get our new direction variable, and this is the reason why I chose 1, 2, 3, 4 starting at left and going clockwise for the directions. So something you might not have known is that you can do a lot of operations on lists that you might not have known about. So you can actually compare, well, you can multiply an entire list by a real number, and you can also compare an entire list to a real number. So we're going to do K is greater than or equal to, and then the list of our key codes. So that's going to be 24, 25, 26, and 34. And this is going to give us a new list that compares each of the elements to K. So it's going to be a list where element 1 is 0 or 1 depending on whether K is greater than or equal to 24. Element 2 is going to be 25 depending on whether K is greater than or equal to 25. So once we have this list, we're actually going to find the sum of the list, and we get that in the list math menu, and you can get to this menu by hitting second and then stat on your keyboard, and then hitting right twice or left once, and you'll get to the math menu. So if we sum this list of K is greater than all of our different key press values, we'll get the number of keys that K is greater than. So if K is 24, it's only greater than or equal to 24. So our direction will be D, and we'll go ahead and store this into D. Our direction D will be 1, because only one of our values is greater than 24, which corresponds to left, which is the same thing as 24. So that's why I chose 1, 2, 3, 4 as left, up, right, and down, because they correspond to ascending key codes. And for instance, if our K was 26, then it would be a list of 1, 1, 1, 0, because k is greater than the first three elements but not the last one. And then it would be the sum of that list, which would give us 3. And 26 does correspond to the right arrow. So if we run this now, we can move our snake around in any direction by hitting the arrow keys. So pretty cool. And we can also hit clear and it will break out of our repeat loop. So the next thing we want to do in this episode is get it so our snake can eat food. And we're going to do that by using two more variables. We're going to use A and B for the location of the food. A as the x coordinate, or the column of the food, and B as the row, or the y coordinate of the food. And we're going to start it out just at 9 on the x, so 9 stored in A, and then 4 on the y. And just like S and T, we can remember that A and B correspond to x and y respectively. A corresponds to x and B corresponds to y because they're in the same column on your keypad as x and y. Same thing that we did with S and T, and it's a pretty common pattern. So now that we know where our food is going to be, we can either draw it only when we create a new piece of food, or we can draw it every time. I choose to draw it every time because it's a little easier. We can draw it B, comma A, and this can be any symbol you want. Just like this O, you could also have it be 0, and it wouldn't change anything. And you can play around with what you think looks the best. I personally think that O looks the best, and I think that an asterisk looks pretty good for the food, but I've also seen people use a plus sign, or you could use an X, or any symbol really, as long as it's different from the snake. Otherwise, you may encounter some confusion. But we're going to use an asterisk, and then we want to check if our x and y coordinates are equal to our A and B coordinates. So if the head of the snake is equal to the position of the food, and we want to do that just after we update our x and y. So we're going to do if A is equal to x and B is equal to y, then let's create some new lines. Then we know that our food has been eaten by the snake, and we want to create a new, or we want to move our food to a new random location. So we're going to do that with the probability function. So we're going to do rand times 16, but 1 plus the integer part of that, 1 plus the integer part of 16 times rand stored into x, and then same thing, 1 plus the integer part of 8 times rand stored into y. So it's going to give us a new x and y coordinate based on the value of random, and our x is going to be between 1 and 16, and our y is going to be between 1 and 8. Now I've actually changed my mind, and I don't want to use this rand because I think it's actually more efficient to use rand int, and it's probably a little easier to understand. So we're going to do rand int between 1 and 16, and likewise we're going to do rand int between 1 and 8. And I believe this is a little bit more space efficient, and it's also a little bit easier to understand. So just forget everything I put before with using ipart and rand, and use rand int. But I believe what I used with ipart and rand would have also worked. So now we can move our food to a new random location. I guess go ahead and test that out. Ooh. Aha. Alright, so I made a mistake, and instead of moving the food to a new random location, we're actually moving the snake to a new random location. So that's why we test frequently. What we actually want to do is store this into A and B. Alright, now if we try this again, we should get something a little better. So yeah, we can move our snake around and go eat food. And this in itself is kind of a fun little game. See how fast you can get to the food. Can you get there in the least amount of key presses in the quickest amount of time, but we want our snake to grow in order to give us the actual challenge of not eating ourselves. So in order to make our snake grow, all we have to do is prevent ourselves from updating the tail. So we can do that pretty easily here by, instead of ending here, doing an else, and then else we want to update the position of our tail. So in this case, if we eat a new piece of food, we're going to move the food to a new random location. Otherwise, if we're not eating food, we're going to update the position of our tail. So if we run this, we should finally see our snake growing. And I had it place the food at the beginning strategically right in front of where the snake is going to be, so that we immediately grow the snake. And that's also for space efficiency reasons. I think it's good to start the snake out as 3. I think that's a good starting length, a good looking starting length. And you also don't have to generate a random position right off the bat. And it's hard to talk while I'm trying to snake. But it doesn't really matter because we can never lose. Oh, but I am enjoying this game of Snake. Alright, so what I was saying is we start our snake out at length 2, but we have it immediately eat a piece of food so that we don't have to generate a random location for food at the beginning. Alright, so man, this game of Snake is fun. I'm so glad that we are doing this. I'm just having too much fun playing Snake, but I should press clear, and now we're finished with our Snake game, and we're gonna wrap up this episode. So in this episode we got our Snake engine pretty much fully working. We're able to grow the snake. The only thing we need to do is make it so that you can lose, and then make it so that something interesting happens when you do lose. So by that I mean a high score system. So stay tuned for part 3. We'll be wrapping this program up, like I said, with the eating yourself and losing, as well as the high score system. I hope you learned something from this episode. If you have any questions or comments, please leave them below. Bye-bye.